Добрый день, коллеги. Меня зовут Александр Беспалов.
My name is Alexander Bespalov. I am a system engineer at Arista. And today I have some slides regarding the in-band telemetry technology. This is my agenda for today. We will look into the options of in-band telemetry for today. We will look at those options that are being discussed now and that exist as drafts. And I would like to draw your attention to the fact that you should not treat this presentation as a roadmap from Arista. Our target here was to introduce new technologies of telemetry to you. Depending on the client's needs, these options will probably be implemented in the equipment. But right now, I would like to tell you about new technologies that are being discussed and that exist as draft solutions. Right now, let's see how a modern data center is functioning. It uses a lot of topology, a multitude of levels, plenty of parallel paths. Alexander tried to calculate those paths. There are a lot of them. And we can have dynamic distribution of the traffic on each level. What do we have in terms of telemetry today? All the equipment is ready to stream telemetry and export the status in the network. It's also ready to export the counters and events. But very often we would like to have more information. And we started thinking about how to get information about the real path that a certain flow of data went through, because we have lots of parallel paths in our data center. So in what section, in what link is traffic being impacted? Today, there are several ways to monitor these things. I put three of them on this slide. At the previous conference, Alexander Klimenko told us about the calculation of TCP retransmits at each link. It's a pretty interesting presentation. There is another solution, mirroring the traffic, which resulted in exceeding the threshold for package buffers. So we can take a package and mirror it into a different interface, and as a result, we'll understand that there is a risk somewhere in the network. And as a result, we can understand what application can suffer or can be jeopardized by this problem. And the third option is traffic mirroring, which resulted in exceeding the buffer and was dropped. So this option shows us that there is a problem. It identifies the problem, and it helps us understand what application is the cause of this traffic loss. So these are the technologies that exist now, that are already being used, but in ITF, there is a working group which is called IP Performance Measurement, or IPPM, and it looks into two options of expanded or advanced telemetry. The first option is called a passport mode. In this case, we'll look into the presentation and show you how it works, but actually each transit nodes adds a portion of metadata to the original package. And then there is additional information added to each package regarding how long each package stood in the queue, and there is also the postcard mode. It's an option where the metadata is not added to the original package. In terms of hardware, it's much easier, but each transit node exports its portion of data to the monitoring station. And I will tell you more about those options on the next slides. Let's look at the INT-IFA technology. It's in those drafts. Those two drafts are interconnected. The first line is the first option of this draft, and the second line is the second version of this draft, which are now being discussed. There are some solution components, which I put here in a simple way. We have two hosts and four transit switches, and this is the traffic flow. Everything is linked to the traffic flow here.
We have Inband flow analyzer domain, which includes all our network devices. The first device downstream is called initiator node. The transit nodes are called transit nodes, and the final node is called terminator node. The main idea behind that solution, certainly, there is a monitoring station, a management station, which configures the networks, collects statistics, and does some analysis, data analysis. The main idea behind it is that we are taking the initial package. The first node would add some metadata to that package. The package goes along the network. Every transit node would add its own portion of the metadata, and after that, at the final hop, these metadata would be cut off the initial package, and the initial package would be sent to the terminator node, and the metadata which we have collected on the way would be delivered to the monitoring station for the analysis. The domain boundaries, how they may look like, the simplest way is to include. So it means that our commutators and our routers or leaves will act as initiators and terminators. The Inband flow actually will act as the initiator. And the second option is that when we want to see a more expanded data in the network, we can start with the inflow analyzer on the servers. So in that case, the leaves and spines will act as just transit nodes, adding their own portion of metadata, and the final host will export that to the monitoring stations. So such an option will require some extra work to be done at the terminating stations. How the headers are added in the Inband flow analyzer. The first node would get the initial package, as I have said, and it will add two headers. First of all, this is the basic Inband flow analyzer header, which is marked in green, and its own portion of metadata. The first hop added the metadata portion dubbed as M1. So the package goes further. The second host doesn't change the initial header, but would add its own portion of metadata. So it would actually add M2 header. The third host would do the same thing. It would add M3 header, and as far as this is the terminal point, what it does, it cuts off the initial package, the initial data and would send that to the receiver and would send the metadata to the observation station. So the metadata may include the identifier of the device so that we could understand, obviously. Every header should be pegged to our network, to some units within the network, so that we can add import and output in order to understand how the flow fared. You can add the information about the outbound queue. You may also add the information about utilization of the outbound port. You may add timestamp of the receipt, when we sent it, when we received it. And therefore, at every hop, we'll understand how long the package stayed within the hop, whether it was stalled by a buffer or not. In terms of the format of the headers, as I said, there are two drafts, version 1 and version 2. According to version 1.0, the header would consist of the basic one, which is marked in green, and the stack with metadata, which would be added by every transit hop or node. In the first version of the draft, it was decided that not to change anything within the IP of the header and to add the event flow analyzer information after the L4 header. And after that, it was decided that probably this is not very reliable. As I said, such a package with additional headers, if it gets out of the network, it would be misinterpreted by the terminating host and will result in some negative outcome. So the second version of the draft implies that a new IP protocol would be added, which says that within the package you may find an event flow analyzer header, and the initial protocol, which now is moved to the event flow analyzer. And there is a stack with metadata available there as well. What options for event flow analyzer are available? So the draft describes three approaches. First of all, here you may find the basic network. This is the original traffic from the initial host to the terminating host. The event flow analyzer may be launched as a standalone probe, which is connected to our commutator, which is being launched, and which from time to time would create some artificial packages with this event flow analyzer header, which moves along the network and which collects the statistics. Naturally, it has to be implemented at the hardware level, and the modern hardware allows for that. But as for the probes are artificial, for instance, it may be ping, which is launched between the final or terminating commutators. The pilot and the real traffic can differ. We can create a lot of probes, hoping that they somehow would be distributed along the network, along our hops, and this is how we're going to monitor it. But there is one more option. You may add this event flow analyzer header to the packages sent by the end users. And we are addressing the problem in the sense that we understand that our telemetrics or the test traffic, the user's packages act as the test traffic. And similarly, it looks good, but there is one negative consequence. Don't forget that on the way, the package would get some new portion of the metadata. So on the way the package would increase in the size. And the possibility arises that if our network on the transit is not fitting the MTU, it means that the MTU package may increase the capacity of the network and will not just lose the monitoring package, but we will lose the application package or the user's package, which matters most. Therefore, there is the third option, which is most balanced, in our opinion. This is, again, we have two terminating hosts which are exchanging certain packages. What the first commutator does, it replicates that package, mirrors it, and makes a replica of the package and adds an event flow analyzer to the header. And this package acts as a test one, goes along the network and goes to the terminating hop, where the telemetric data would be sent to the monitoring station, and the copy of that package would be just skipped. In that case, as far as we are sending a copy of the user's package, we can guarantee that on the way, the routes of the monitoring and the initial package would coincide, and the initial package remains unchanged. So it means that once our network lets through the event flow analyzer header, we can be sure that it will not affect the final traffic. It's been supported at the hardware level. So Broadcom Trident 3, Trident 4, Broadcom Tomahawk 4, Broadcom Jericho 2, and barefoot Intel Tafina 2. This all supports that. It should be noted that on that slide again, we find a technical opportunity to implement that this or that matter. What we can do with the devices which do not support INT at the hardware level. So we have a postcard-based telemetry. So its basic description is available from those two drafts. You're invited to study that if you have time and desire. Why postcard-based telemetry emerged? First of all, there was a desire to avoid the harsh requirements to the hardware. Actually, it is a very labor-intensive thing when the metadata are being added to the header at every hop. But still, there are ASICs which have been produced several years ago, and technically they cannot implement that. Besides, postcard-based telemetry can be launched directly from the CPU of the device. So if the CPU is quite old and it cannot add the headers and put timestamps at the hardware level, we still can move the function to the CPU of the device. It would be less accurate measurement, but still it will allow to get some picture as to what is going on. Again, the problem with the MTU, don't forget what we discussed before, the metadata, increase the size of the package, and this is the problem which you have to address somehow. One more thing, postcard-based telemetry allows to send the data out of band. So it means that every node would send its own portion of telemetric data to the monitoring station and can do out of band. So it means that we can rule out the impact of the monitoring traffic to the real queues, which are being used for the final traffic, for the traffic of our applications. How this all works and what regimen are being discussed within drafts. So first of all, this is instruction-based regimen. Again, we have our network, two final nodes, and the traffic flow between them from left to right. At the first hop in our network, we have to configure a kind of a policy for choosing the packages. It might be a filter, or it might be sampling, when we choose every 1,000th package, 1,000th package, and we try to monitor the way it goes. After that, we have to identify what data we'd like to export to the monitoring station. And the set of data certainly would depend on the component base our commutator rests on. So it depends on the ASIC and what it can add to that. And an important thing here, the first package would go to the commutator. What happens? This package would be complemented with a header with instructions, and the instructions would define what data have to be exported to the monitoring station. Have a look there, this policy. And the configuration is done at the very first host, at the very first commutator of our network. And naturally, the data would be exported to the monitoring station. After that, the package goes along the network, and every interim node getting a package with a special header, which defines the instructions, which says that certain monitoring data have to be sent to the monitoring station, would read these instructions, realizing what data have to be collected and sent, and finally these data would be sent to the monitoring station. This header acts as a trigger for the subsequent hops and subsequent nodes. It's quite convenient because it is configured only at one hop, and other nodes just follow an instruction, but there is one disadvantage: this initial header added to the first package. And it means that it has to be implemented at the hardware level, which is not available for the obsolete ASICs and obsolete CPUs. There is another regimen called marker-based regimen, the same monitoring station, the traffic flow, but what goes on? At the first commutator, we also configure the policy of selecting the traffic for monitoring. We would configure the data which we would like to export, and at the subsequent nodes, it would be enough just to configure the data sets which we would like to export to the monitoring station. What goes on? We get the initial package, and it only takes to add a kind of a marker. Then, following that marker, every transit node would understand that once the marker is there, so this is to understand that we have to export the data to the monitoring station. What can be used in case of a marker? You may use flags in the IP header. We can use unused TOS. You can use TEI and CFI bits. The advantage of that method lies in the the fact that not necessarily have to add the headers. It may be implemented at any hardware, at any outdated configurator. Only thing you have to bear in mind, you have to agree on how you're going to mark the traffic. But again, it would be enough just to actually configure one bit, which acts as a trigger, saying that this set of data has to be sent to the monitoring station. And the third option, which is the simplest way, which doesn't require anything, any changes in the initial packages. So how it looks like. At all the nodes, we would configure the same policy using the filter for all the nodes. And we'll configure for all the nodes the dataset. And only thing the network does, if this package goes to that filter, the data about that filter would be exported to the monitoring station. The initial package remains unaffected. Nothing is complemented to that. This is the simplest and less demanding in terms of the hardware option. The way you take actually will depend on your requirements and the requests of our customers. Hardware support. I have scratched the surface of that issue already. The marker-based and policy-based options can be very easily implemented at all the hardware types because they do not need any headers to be added, and it should be noted that as far as we don't have to add any new headers to the transit packages, this option of telecard-based telemetry can be moved or installed at the CPU commutator. So it means that we will not somehow monitor the whole traffic, but will monitor just selected pieces of flow just in order to have a glimpse of what is going on within the network. And finally, what we have here, let us get back to the flow chart, which I used at the outset. So we have extended the IP performance monitoring to IP performance measurement, and you have two modes or regimen, passport mode and postcard mode. And there are four types of telemetrics: in-band flow analyzer, instruction-based, marker-based postcard mode, and policy-based postcard mode.
If this is interesting for you, please look into those drafts, and we will be looking forward to your feedback. You've got my contact details as well as those of my colleagues, and we will be happy to hear your feedback. That's it for me, dear colleagues. I was happy to present this information to you. Thank you, Alexander. I can see that we had two questions in the chat, but we've already answered those questions, so we are not going to ask them live. But Alexander, please go to the chat room, and I think there will be people who will be happy to talk to you.